My name is Jason Grillo with AirMiners, and great to see you all here for our event highlighting XPRIZE milestone winners. Indeed, things are getting better all the time, especially in our CDR environment. So the way we're going to do our event today is have the milestone winners who are in attendance present their companies for maybe 2 minutes each. By the way, there will be no slides today, so you don't have to track down what the winners are going to be presenting from a physical PDF or PowerPoint standpoint. That said, after we cycle through all of the teams who are presenting, we are going to go to breakout rooms where each team will be in a breakout room for the second half of our event today. And you can float from room to room and ask them questions, learn about the challenges, solutions that they have achieved along the way for their journey in carbon removal, so that you can complement your own journey in carbon removal. Then I'll come on at the tail end with a couple of announcements, and then we'll be out. So the first half with the presentations is going to be recorded. The breakout rooms will not be. So that way, it's a little bit easier on us to not have 10 different recordings floating around. Like I said, just the first half, the first 30 minutes will be on our YouTube channel, hopefully in a few days. With that, I'm going to share or reshare the order of presentations today. So we're going to start with 8 Rivers and Mr. Adam Goff.
Hey, Jason, can you hear me all right?
Yes, I can. So go ahead. We're going to start. Whoops. Everyone's going to have 2 minutes to go, just so that we are respectful of everybody's time and of our audience's time. Thank you very much. So, okay, if we're all set to go, Adam, feel free. Go ahead.
Thanks, everyone, for joining the call today. My name is Adam Goff. I'm an SVP of Strategy at 8 Rivers Capital, and I'm the lead of our Calcite carbon removal technology, which is our direct air capture technology that was one of the winners of phase 1 of the XPRIZE. So 8 Rivers invents and commercializes carbon capture technologies, and we do everything from clean power, kind of best known for the net power technology, to clean hydrogen to direct air capture, having raised a couple $100 million into our technologies over the last decade. We were really excited to win the XPRIZE. We hadn't actually launched our technology yet, so this is probably the first you're hearing of Calcite. The story of it, we invented it back in 2019. It's a calcium cycle-based direct air capture technology. We then won grant funding from RPE in partnership with MIT, did lab scale testing of the technology, and that kind of completed at the end of 2020, used that at the end of 2021, and used that data to apply to the XPRIZE. How the technology works. So we're just cycling calcium. So we have a kiln where we feed in limestone, which is CaCO3, to form, heating that up to form calcium oxide. That calcium oxide, we then hydrated to form calcium hydroxide, and then we have an air contact with forced air, so fans pulling air across calcium hydroxide with high surface area so that it carbonates both quickly, so it quickly turns that calcium hydroxide into calcium carbonate, and to high extents. So we're getting over 90% conversion of the hydroxide to calcium carbonate. That calcium carbonate is the raw material we can feed right back into the kiln. So we're able to use that calcium cycle to rely on existing supply chains and fairly well understood materials to do direct air capture. So it's an approach we've taken that we think is low complexity, also with the potential for low costs. And I guess the last thing to note for people who are familiar with calcium, looping through hydroxide is key to not have reactivity loss. So calcium oxide looping leads to reactivity loss. By going through hydroxide, you can get much better performance. And right. Jason, I think that was my alarm. So thanks, everyone.
That was perfect. Thank you, Adam, and others. Feel free to ask questions in the chat, but we can also pick those up in when we get into the breakout sessions. And for those watching, just realize it's going to be recorded. So if the participants are going a little bit too fast, that's fine. We'll have it up on our YouTube channel so that you can replay it and replay it again so that you can understand better what each person is saying. So next up, we've got Robert Brown from the Bioeconomy Institute. Robert.
Thanks, Jason. I'm Robert Brown. I'm a professor of engineering at Iowa State University. I'm also the director of the Bioeconomy Institute. So we're a nonprofit team, which we refer to as the Bioeconomy Carbon Removal Team. Our approach is to use pyrolysis of biomass, and hence we're going to let nature do the photosynthesis to capture CO2. We then process with an engineering technology the biomass into biochar as well as other co-products. So what makes our technology unique, I'd say there's a couple of things particularly. We use a variation of pyrolysis, which we call autothermal pyrolysis. In this technique, rather than providing heat externally to the reactor, we actually add a little of air to the reactor, which has internal partial combustion exothermic reactions that then provide the heat necessary to drive the pyrolysis reactions. This results not only in a simplification of the reactor, but a tremendous intensification of the process. We estimate probably a threefold intensification over what conventional pyrolysis could accomplish. Also unique is, in addition to biochar, we're producing other co-products that valorize the whole operation. In fact, our goal is to make those co-products pay for the sequestration of the carbon. Right now, we've tested this in a continuous reactor at about a half ton per day. That was the basis of our XPRIZE application. We have constructed, have not yet commissioned, a 50 ton per day system. So that's a 100-fold increase of what we do. And by that measure of tonnage is the biomass that goes in. In terms of the carbon sequestration, of course, the carbon prize requires 1,000 tons sequestered over the course of a year. This 50 ton per day biomass processing will actually accomplish that within 3 or 4 months of operation. And that's my summary. Thank you, Jason.
Excellent. Next is Carbin Minerals, Bethany and Paul.
Thanks, Jason. Yeah. Hi, everyone. I'm Bethany Ladd, co-founder and COO of Carbin Minerals. We're based out of Vancouver, Canada. And we are a spin-out of our research lab here at the University of British Columbia, based on decades of research led by Dr. Greg Dipple in the field of carbon mineralization in mine tailings. And so that's what we do as a company. We've brought the research out of the lab into the world to scale up rapidly. And so we developed technology to accelerate the process of carbon mineralization. And real quickly, what that means, it's the process where CO2 binds with certain constituents and certain types of rock to form a secondary carbonate mineral, which stores that CO2 as rock for geologic timescales. And so importantly, we work with the mining industry because by their very nature, they dig up and crush a lot of rock, which creates this enormous feedstock for this process. And so as a company, we're focused right now on direct air capture, using the mine tailings to capture CO2 directly from the atmosphere and store it as rock. And we manipulate and treat tailings, partnering with the mining industry to implement those technologies into their mining operations so that they can mine not only for the metals that are going to be necessary to supply this clean energy transition, but also they can mine for carbon removal. And we always joke in our company that we should have been called AirMiners, but we'll leave that to you guys. And so we're incredibly excited and honored to be among these great group of companies to have won one of the XPRIZE Awards. And so looking forward, we are quite early stage, so we are going to be using this to grow our team and roll out our first pilot at a mine site to demonstrate our technology. So, thanks, Jason.
Wow, and spot on with 2 minutes. Well done. So here we go. I mean, as much as the mining industry might be crushing it, Bethany and Paul and Carbon Minerals are also there to mine to remove carbon as well. So with that, also noting that Bethany and the Carbon Minerals team are part of our current Launchpad batch. And if you are part of a carbon removal early stage startup, think maybe 1 or 2 or 3 people, maybe pre-seed, maybe seed stage, then Launchpad is the place for you. So launchpad.airminers.org. I'll share the link later, but that is a place for you to get accelerated on your path to on your path to viability, sustainability for the environment and for your company. So, so there we have it. Next up, Carbin. Hans, please.
Yeah, thanks, Jason. Yeah, Carbin is a Dutch company, a Dutch startup company, so based in the Netherlands, in Holland, which is why the background looks as flat as it can be, because there's hardly any country I think that you can find which is as flat as the Netherlands. We're a spin out of TNO, which is a research institute in the Netherlands. And we leverage technology that was originally developed for solar panels. We developed a new material, an air filter, if you want, very much like what Climeworks is doing or what Global Thermostat is doing. But we kind of accelerated the process of capturing air. So we can do saturation of the material in orders of minutes, reducing the cycle time, and so increasing the yield of the machine, so kind of reducing the capex cost per ton of CO2 that you can yield with the machine. The machine is kind of, now I should turn the other side. The machine is kind of the one you see on my back. It's a kind of tower, so air is being drawn in from the top, and then it's kind of guided across the sorbent material. And at the bottom, we blow out again the CO2 depleted air. So it's an air filter system. It's based on a thermal swing. We use vanilla type amine. So amine chemistry, of course, very well known for flue gas capturing. So we do not very much different from a chemistry point of view, but the trick is to accelerate the process, which we do by means of atomic layer deposition. So we use those materials as an atomic layer instead of in a bulk phase. So, and the XPRIZE money, well, we'll use it to tune up our team, because indeed we're also in an early stage. We're 12 people right now, and we'll need all the hands we can to build the 1,000-ton pilot machine, of course, that XPRIZE asked us to do was by 2024. That's my 2 minutes.
Right on. Okay, awesome. Next up is Axel Reinaud at Net Zero.
Thanks, Jason. Glad to be here. So I'm Axel Reinaud. I'm one of the founders of Net Zero, and I'm the CEO. So we are a biochar company, a bit like what was explained by Bioeconomy Institute. What is different with us is that we operate in tropical developing countries, where biomass is super abundant and actually totally free or almost free. So that allows for us to build a very cost-efficient model and hugely scalable. And that's the secret sauce of what we do. Biochar is well known. It's the way we operate and the technology on which we operate that allows the model to be super efficient in terms of production cost of the carbon removal credit. We have built a full-scale MVP in Cameroon, doing 1 ton per hour of crop residues. And we are now replicating the model in Brazil. I think for us, XPRIZE was great news, huge motivation for the team. I think that's the #1 thing. And now they think they can accomplish everything. I think the second thing was really interest from a lot of partners, and that's very useful for us. And then the money, we use it for R&D, so we'll allow to accelerate. I think for us, the next step is to start to demonstrate the replication of our model in Brazil. So we'll start building a second plant there in June. And we also have an upcoming capital raise that we were kicking off next month, beginning of June. So actually, all of this comes pretty handy. That's the story, and I'd be happy to answer questions in the breakouts.
Excellent. Excellent. Great to see solutions being deployed in the global south and across the world. So, and there are several companies today in our event and also across the XPRIZE milestone winners and across the entire XPRIZE array of applicants who are developing solutions in the global south. So awesome, awesome. Next up, Planetary Technologies.
Hi, everybody. I'm Greg Rao, co-founder and chief technology officer at Planetary Technologies, formerly Planetary Hydrogen. We're a Canadian-based company, Ottawa and Halifax, although three of us are working remotely here in the San Francisco Bay Area. Planetary is developing an electrogeochemistry method of generating alkalinity that we add to the ocean as a CDR strategy. What we do is take mine tailings and we use that in combination with electricity and water to generate magnesium hydroxide, hydrogen, oxygen, and an acid. And we recycle the acid to process the mine tailings to remove the magnesium that we ultimately make our magnesium hydroxide, which we then add to the ocean. It is an energy intensive process, but we think one of the advantages of our system is that we are not just doing carbon dioxide removal, we're generating hydrogen. And we're also extracting some valuable metals from that, from the mine tailings in our processing. So because we have multiple products, we think the revenue from that can drive down the net cost of carbon dioxide removal. So we'll be happy to answer questions in the breakout, and we're very honored to be part of this group. Thank you.
Thank you. Okay, next up is David Hughes.
Thanks, Jason. Hi, folks. So my name is David Hughes. I'm the founder of Plant Village, which is a global platform out of Penn State University. I'm also the director of the USAID Innovation Lab and Current Emerging Threats to Crops. Edward Amoa is here with us on the call, also from Plant Village. So we won both the student prize for monitoring and evaluation, as well as the milestone prize. We won the student prize for using our global platform, Plant Village, to register carbon, either as it grows as trees or wherever else one stores it from nature-based solutions. We do a lot of this through AI and cloud compute. We're operational in 60 countries and 30 languages, and we had that $39 million investment by Congress for an innovation lab. So we're leveraging our platform, which is helping the global south cope with climate change, to then leverage the power of the global south to draw down carbon. We reach about 15 million farmers a week. Our model is AI-powered carbon capture cubes. So we scale up tree production, we distribute trees to farmers, we plant them along the edges of the fields. Those trees are then converted pyrolytically into biochar that's stored in the farm, that benefits the soil, helps the farmer with climate change adaptation. But the whole system is on our global platform, which is leveraging the ability of farmers to use the smartphones we provide. We put the whole system onto blockchain, so we can have tracing and transparent systems, which can then automate the payment. We reach about 14 or 15 million farmers in the next couple of years through our innovation lab. We will get to about 150 million farmers a week. And the idea is that we can leverage that huge number of individuals to draw down carbon. In addition to nature-based solutions, we're also exploring weathering from concrete onto the fields, then the green concrete aspects, as well as direct air capture, because we want to just leverage the platform we have to do this multiple things at once. Thank you.
Spot on. Excellent. And also noting that David and Plant Village Carbon for Good team are Launchpad alumni as well. Next up, Takachar, another Launchpad alumnus, and Vidyut, please.
Thanks, Jason. Hello, everyone. Vidyut here. I'm the co-founder and CEO of Takachar. And the mission of Takachar is to advance climate justice, to enable smallholder farmers to create value out of their crop residues and create valuable products like fuels, carbon negative fertilizers, activated carbon, etc. And our thesis is that, what we have developed is small scale, low cost portable equipment that can be just latched behind tractors and taken directly to farms to process these wastes in situ. And what that allows is it reduces a lot of the logistics costs of transportation of this loose, bulky and wet agricultural waste, which we think is a cost barrier, but also at the same time creates value at the site of the farmer's location. Till now, we have been producing carbon-rich fertilizers, essentially producing biochar out of rice-based residues, and have been selling that to 5,300 farmers till now in Kenya, and have broken even and have broken even in the process and are profitable in that. Also, at the same time, we have seen farmers achieve a 27% increase in their crop yield because of this. We are now scaling to India as well, where we're using rice straws that are burned by farmers in the open and make a similar biochar-based fertilizer. And this is together with the World Food Programme. Apart from this, we also have some other pilots that are not in the carbon removal space as such, but use other kind of crop residues to make other carbon-rich products like activated carbon and also fuels. So that's my summary, and looking forward to interact with everyone.
Thank you, Vidyut. Last and hardly least, it's a pleasure to have Steve Oldham here from Captura.
Thank you, Jason, and apologies for not being able to join until now. Captura is a direct ocean capture company. So fundamentally, carbon removal is difficult because CO2 in the atmosphere is 400 parts per million, give or take. So to remove a meaningful quantity of CO2 from the air, you need to touch or move an awful lot of air. And that's the fundamental challenge. Captura proposes to solve that challenge by using the ocean. Today, the ocean captures about 30% of all the CO2 we emit. If we can pull CO2 out of the shallow layer of the ocean in a non-harmful way for marine life, the ocean will respond by pulling 30%, the same CO2 amount, directly out of the atmosphere. So our technology was created at Caltech in California. We're about to put our first system in the water in July of this year, and we'll be using the ocean as the medium to effect carbon removal at massive scale worldwide.
Awesome. Great. And thank you, Steve. And thank you, everyone, for your quick presentations. We're at 25 minutes after the hour, so a little bit ahead of schedule, which is always a good thing. I have put in 9 different breakout rooms, which I'm going to open up momentarily. At that point, each of the presenters will go to their respective room, and also you as an audience can get to pick and choose which room you go to. You should be able also to leave that room, come back to this main room, and then join another breakout room after that. Just be sure to click the blue leave room, which will pop you back into this main room here. I'm going to stay here just to provide some mission control for the whole activity, but we'll be there until maybe, see, 5 minutes before the top of the hour. So it should have you should have about 30 minutes in the rooms. I'm going to open them now, and then when they open up, go for it.